Hi children, today we are going to learn very important topic differentiation. We need to understand what is the use of learning differentiation. Actually, differentiation we use in the question which is involved with mainly gradients. In previous lessons, we knew that if you want to find the gradient of a straight line, we have used the equation gradient m is equals to y1 minus y2 divided by x1 minus x2. But when we need to find the gradient of a curve which is not a straight line, what is the procedure we have used to find the gradient of the curve at a given point x0? The easiest way where we know to find the gradient is first we need to draw a tangent to the given point. But the practical problem of drawing the tangent is it's very hard to find the exact tangent to a given point, because you can understand from this graph itself the red color line and the black color line, those are two tangents I have drawn to this curve. But just looking at this curve, we cannot tell that which line is the best line as a tangent to the given curve. That is why we use differentiation to find the gradient of a curve. Before we learn how to do the differentiation, first we need to learn about differentiation notation. Usually, the differentiation of a function is given by the form of d by dx. That indicates you can differentiate the terms of x. From the first example, it's given as dy by dx. That means y is a function where you need to differentiate, and the dx in the denominator indicates you that we can differentiate only x terms in the function. If you come up with the second example, that is dy by dt. That means the function y should contain only t terms, whereas we can differentiate only t terms because the denominator is dt. But for example, if you get d by dx of x to the power 5, that is possible because the differentiation variable is x and the function also x. But if you come up with d by dx of k to the power 5, that is impossible. The reason is that differentiation variable is x, but the function is in terms of k. Now we are going to learn the differentiation rules, which involves us to identify how to do a differentiation. In this chapter, we are going to learn two main rules which is available in your IGCSE syllabus. The first rule: if you have to differentiate x to the power n, the notation is d by dx of x to the power n. That indicates you that you need to differentiate x terms in the function, and the function is x to the power n. The answer is n times of x to the power n minus 1. Let's try to understand from this example 1. Here you have to differentiate d by dx of x to the power 5. That means in this question, what is n? N is 5. Therefore, the answer is 5 times of x to the power 5 minus 1, which turns into the final answer 5x to the power 4. Let's try to understand from example 2 as well. There you have to differentiate x to the power 14. Now what is n? N is 14. Therefore, your answer is turned up into 14 times of x to the power 14 minus 1. So the final answer is 14x to the power 13. Hope you understand this topic. Let's try to learn rule number 2. Rule number 2 is if another constant k involved with x to the power n at differentiation. If you want to differentiate k times of x to the power n, simply you can take this constant k out. Then d by dx of k times of x to the power n turn up into k times of d by dx of x to the power n. Now you can simply do differentiation of x to the power n and final answer turn up into k times of n x to the power n minus 1. Let's try to clarify from example number 1. If you want to differentiate 10 times of x to the power 5, you can take this 10 out and you can write 10 times of d by dx of x to the power 5. Where you can apply the formula with rule number 1 and turn up into 10 times of 5 x to the power 5 minus 1, finally 50 x to the power 4. From example number 2, there you need to differentiate 4 times of x to the power 20. Turn up into 4 times of d by dx of x to the power 20 and simply turn up into 4 into 20 times of x to the power 20 minus 1, turn up into 80 x to the power 19. Hope you have understood.